participation up on that blue board. Even if you are giving it a guess, it's cool. This is why we're in school. Oh, I think I rhymed. Woohoo! Make sure you get that up in the board there. We want to see more participation. Yeah, and we want to know what you're interested in, what career you're interested in. I'll put the career I'm interested in. Teacher. Ha 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 ha. All right, so let's get some more participation up there. Attendance is going up into the chat box there. Nope, that's Maylin, and that is A-OK if you are there. Awesome, Angel. I know I read your survey. I love it. Love it. Super cool. Super cool. All right, let's get some more participation. I do want to get some more. I see a couple people up there. Maylin, awesome. I see Maylin again. I see, let's see who this is. Miles, nice job, Miles. Nice, Tayan, mechanical engineer, smarty pants. I know I couldn't even do it. No way. But that's James. I've never heard. That is such a trade. I love it. Of being a butcher. That is awesome. Marine biologist, Alan. See? Look at that. So unique. This is great. Yeah, I mean, again, totally just get it out there. Mrs. Larkin was going to be a marine biologist. I was going to be a physical therapist. That's what I was going to be. But here I am being a teacher. All right, so let's go ahead and go through this again. We do want some more participation. I don't know if you're just kind of confused on where to go or how to go. So again, what type of matter is in a chocolate chip cookie? Use this right here. Use this diagram in order to figure it out. Ask yourself this first question. Can it be separated physically? Can I take a chocolate chip? Can I separate the pieces out of a chocolate chip? Can I take the chips and separate them out? Can I take if you put nuts in your chocolate chip, can I separate the nuts out of those chocolate chips? If you can, and I can physically do that, it may be a nuisance to do all that, but if I can, then you're going to answer yes. And then you're going to proceed to question number 2. Is the mixture uniformed? Is it same throughout? Remember what heterogeneous means? Hetero means different. Homogeneous means the same. If I go ahead and I pull a piece of chocolate chip cookie, and if I pull a piece of chocolate chip cookie, is it all the same? Or is it going to be different? Am I going to have more chocolate chips in one section, or am I going to have the same chocolate chips in that same section? If I can answer no, that it is different, then it is going to be a heterogeneous mixture. Okay, heterogeneous mixture. Excellent. Whoever put that up there, nice try. So let's take a look at the second one. What type of matter is theobromine? Okay, theobromine, a substance found in chocolate. So ask yourself this first question. Can it be separated physically? Can I separate all of these elements separately? No. If I cannot, then I need to proceed to question number 3. Question number 3 says, can the pure substance be separated chemically? Can I break this chemical reaction, this chemical compound down? Yes, if I can, then it is a pure compound, and I just kind of gave it to you. So yes, I can. If I can break this up, then I can. It is then a pure compound. If I can't, then it's a pure element. But a pure element, remember, is if you take a look at the periodic table, is just one of those squares. That's an element. Iron is an element. Gold is an element. One single atom is an element. All right, so excellent job on this one. Beautiful. So let's take a look. What are the careers that you're interested in? I'm seeing it pop up into the chat box. Excellent. I want to be a YouTuber. Ignacio, I can't stress I'm not being with you in the last class. That's totally you, buddy. That's totally you. The ladders union. Ooh, what is that one? Ooh, that's interesting. I like that one. Anthony, what is that one? Bus driver. Excellent. Yeah. Ladders union. Let me know in the chat box. That seems pretty cool and interesting. All right, so let's go ahead and move on because we do have a lot of stuff. Mechanics, awesome. I see mechanic up there, beautiful. So just remember that our Class Connect norms and expectations, please do not share any personal information or information of others into the chat box for your protection and protection of others. Make sure you're participating. It is extremely vital to participate and expected to use microphones, webcams, and proper tools when asked. Make sure they're school appropriate because obviously violations can result in a verbal or written warning and then obviously a exit of class. So let's not go there. All right, so let's go ahead and open up our attendance check. Those attendance links have been popping up into the chat box, so make sure you get them in there. Make sure you get them in there. They're only going to be there for the first 15 minutes of class. After that, then you no longer have them. If you want to do this later, which you can, it does close at midnight, make sure you write that word down and go back to it. You can always find it in your grades tab for you. So again, make sure that you get that in. All right. With that being said, I think we're going to go ahead and I think I'm going to, yeah. All right. All right, let's go ahead and move on. Make sure you get your attendance. Again, just a reminder, it is 10% of your grade. It is 10% of your grade. So let's move on. Scheduling today is week 2 of our 13-week adventure. It's day 5 of our 60 days together. It is Tuesday, December 1st, and we're going to talk about phase changes, and we're going to do this through slides 12 through 17. So we're going to go through a lot today. Oh, Mrs. Larkin's fixing her keyboard. All right, so let's go ahead and today, obviously, remember, just a reminder, so the heads up, Unit 1 project is due on Friday, December 4th, okay? Just December 4th, my son's birthday. He's gonna be 3 years old. I cannot believe it. Where has the time gone? All right. So today we're going to talk about defining phase change. We're going to define and identify different types of phase change, and we're going to define and identify endothermic and exothermic processes, and doing this through our slides 12 through 17. I know, happy early birthday, Tim. I know, he's so sweet. All right, here we go.
Beautiful. All right, everybody. So at this point, this means that we need to go ahead and open up our projects. If you have already started your project, then if it's the Google version, please go ahead and open up the Google Slides folder. There's the link to that, and open up your Google version. If you are using the PowerPoint version, that one's already saved on your computer, so open up that version and then raise your hand when you're ready. If you have not yet started the project, remember we've been working on the project for a while and it is due on Friday, so we need to get it started right away. Please go to your Grades tab. Here is my Grades tab for Mrs. Larkin. Here is the Grades tab for Mrs. Sepulveda. Right there, and go to your Grades tab. There are 2 versions. Again, there's a Google Slides version. Click on that, click make a copy, or there's a PowerPoint version. Click on that and click download. Alternatively, if you have a hard time having multiple things open during class, you're also welcome to take screenshots, photos, or write notes and then work on it after class. So that's totally fine, but still raise your hand if you're going to do that alternative as well. So I'm going to go ahead and give you 20 seconds to get it opened and ready to go, or copied if you have not yet started it. So 20 seconds, raise your hand if you're ready to move on. Raise your hand when you are ready to move on. 10 seconds remaining. So Angel, so elements in your food are going to be due to the air that is in your food, which either means that you have oxygen or nitrogen. Those are the 2 components of air. So you can choose oxygen or nitrogen. You can also choose, what was the other one that I talked about? Oh, I talked about how you can also talk about the pan that you use. Pan that you use, which could be aluminum, could have iron in it, it could have copper in it. Those are also options. Those 3 are also elements. Perfect. All right, waiting on raised hands from Adriana, Ame, waiting on Annabelle, Angelo, Aria, Bryce, Christopher, waiting on Derek, Derek with 2 R's, waiting on Dion, Gabriel, Jade, Jadelyn, Patrick, and Timothy. Please raise your hand when you're ready to move on. Go, go, go. Awesome, looking good, looking good. All right, lowering those hands. If you didn't raise your hand, I'm just expecting that you'll get it done in a moment. All right, let's go ahead and start off with a brainstorm. So in the chat box, if I want to boil water, do I need to add heat to the water, or does heat need to be lost from the water? Go ahead and tell me in the chat box. Okay, yes, no worries, Jadelyn, thank you. If I want to boil water, do I need to add heat or does heat need to be lost? Yes, we need to add heat, absolutely. So we need to add heat. That heat comes from the stove, right? So that should make sense. That's literally why we put it on the stove. The heat goes from the stove into the water to make it hotter and hotter until it boils into steam. Beautiful. Now, on the other hand, let's take a look here. If I want to freeze water, then in this instance, should I add heat to the water or should I make heat be lost from the water? Should heat be added or lost from water to make it freeze? Yeah, we actually want to lose that heat. Absolutely. We want to lose that heat because if we lose that heat, then it will get colder and colder and eventually freeze into ice. Now, these two concepts are going to be related to today's topic, which is phase changes. And phase changes are when matter changes from one state to another state due to thermal or heat energy being absorbed or released. So one state, right, meaning gas, liquid, or solid, changing into a different state. The only one we're not going to talk about during our class right now is plasma, just because that's a little bit more complicated, okay? But based on this, we should be able to tell that when we add heat or lose heat, it's going to change its phase, right? We talked about heat being absorbed or added. That was like in boiling. Heat being released or lost. That was like our example of freezing. Now, remember that these are only physical changes because chemically, your substance is still chemically the same. Take, for example, water. Whether water is a solid, a liquid, or a gas, it is still what chemical? Tell me in the chat box, what is the chemical for water, chemical formula for water, regardless of if it's a solid, liquid, or gas? Thank you, Rose. Thank you, Gabriel. Thank you, Stephen. Yes. Anthony, we did. You could scroll up. We'll go ahead and send out the links again, though, for you right now. So there's my link for Mrs. Larkin. Here's the link for Mrs. Sepulveda. And then the start of class word is going into the chat box. Let me copy that. There you go. All right. That will disappear in 4 minutes. So get that done now. Yeah, it's H2O. No matter what, they are all H2O. So solid, liquid, gaseous, water are all H2O. So therefore, this is only a physical change, not a chemical change. Emoji in the chat box if you feel comfortable with that. Thank you, Kale. Thank you, Ignacio. Emoji in the chat box if you feel comfortable with that analysis, that this is only a physical change. Thank you, Rose. Thank you, Annabelle. Perfect. Camilla, Miles, Alan, thank you for your participation. Love it, Malin. Alexis, awesome. Thank you, Ignacio. Perfect. Let's move on. So let's go ahead and analyze these types of phase changes. I would say 3 to 4 of these you're probably pretty familiar with. 2 to 3 of these might be new to you. So let's go ahead and take a look at them. When we melt something, that means it's going from a solid to a what? I'm betting most of you know this one. When we melt something, it goes from a solid to a what? To a liquid. Yes, melting is actually turning it into a liquid. This is like when we have ice and we leave it outside of the freezer, it eventually melts back into liquid water. Great. Now, freezing is the opposite process. So freezing, we start as what and then turn into a solid. Freezing, we start as what and then turn into a solid. Yes, exactly. We start as a liquid here. Absolutely. We're going to go ahead and start as a liquid, which should make a lot of sense. Again, this is like if we have liquid water, we stick it into the freezer and then it freezes and becomes solid ice. Great. Now, vaporization, I'm betting most of you also know this one. Vaporization has many different forms, right? It could be evaporation, like on a hot day, or it could also be when we boil water. So in both of those cases, we're starting with a liquid and turning into what? Yes, exactly. We're turning into a gas. Great. So this is an example of vaporization. Beautiful. Now, condensation is the opposite. So condensation, what do we start as? Condensation, yep, we start as a gas and we end as a liquid. Now, even if you might not have known the word condensation, I'm betting you've experienced it before. Tell me in the chat box, yes or no, how many of you experience this, where you have a cold bottle or a cold drink and you go outside on a hot day and then it starts to sweat. How many of you have ever experienced that? Yes, it gets all sweaty on the outside. Now, your soda bottle, your water bottle are definitely not actually sweating. That would be pretty nasty. Or yes, on your car window. Exactly, James. That's a great example. So they're not actually sweating. What's happening here is that you have gaseous water in the atmosphere. So that's my picture of gaseous water. So gaseous water in our atmosphere. And when that gaseous water hits a cold water bottle, it cools down. right? So let me change this. So it cools down, and as it cools down, that means it's going to begin to turn back into a liquid. So it goes from a gas and cools down into a liquid. Emoji, if you feel comfortable with that. Again, condensation might not be as familiar. It's just the opposite of vaporization, and I'm betting you've experienced it before. Good, thank you, Derek, with 2 R's. Is our Derek with 1 R here today? No, he's not. All right. Looking good. Thank you, Shelby. Thank you, Daniel. Perfect. Now, sublimation is a pretty cool one. If you've ever played with dry ice, which is frozen CO2, so dry ice is frozen CO2, carbon dioxide. Frozen CO2 instead of frozen H2O, frozen CO2 actually starts as a solid and then immediately turns into a what? Take a look at this picture here. What do you see being formed? What do you see being formed here? Yes, you should see some gas being formed here, which is super cool. All right, now this should make sense because you actually breathe out CO2. You breathe out carbon dioxide, and you're breathing out right now gaseous carbon dioxide. You're definitely not breathing out frozen chunks of CO2. That would be painful and disgusting. Okay, so you are breathing out regular gas at room temperature, right? But solid CO2 is so cold that as soon as it hits room temperature, that's such a big difference in the temperature that it's going to go ahead and it's going to immediately skip the liquid phase and go straight to a gaseous phase because that temperature is so big. I actually don't know how fog machines work, but I do know that you can use you can use dry ice to make fog like happen in your like drinks and stuff. So dry ice won't really hurt you unless you have too much of it. Don't put it in your pools because that can actually suffocate you. But you can put it in like to drinks and stuff. And it will turn into witch's brew. All right, I'm going to go ahead and send out the attendance one last time. Actually, Mrs. Sepulveda will do that. She's going to send out link for my class, link for her class, and then the start of class word. And then in about 30 seconds, we're going to go ahead and erase the chat. So make sure you get your start of class word if you haven't already. Yeah. All right, looking good. Now, deposition is going to be the opposite. So we already talked about this. We're going to start as a gas and turn into a solid. Now, this one you've probably experienced as well. How many of you have ever walked outside on like the first cold day right before winter starts and you see frost all over the grass or the leaves, et cetera, et cetera? Tell me in the chat box, yes or no. How many of you have ever seen frost before? Yeah, so frost is an example of deposition. So same thing here. We have water, gaseous water in our atmosphere. And what happens here is this time when it hits our cold leaves and our cold grass, it gets so cold that it actually skips the liquid phase that we would have gotten in condensation and instead turns straight into a solid. So that is an example of deposition. You can see the word deposit. So it sounds a lot like gas is being deposited onto a substance being frozen. All right, so let's go ahead and begin to work on one of your slides for this.
All right, so let's take a look at slide number 12. So slide number 12 is a drag and match. So you're going to answer from the previous slide that we're just going to do, but let's go ahead and talk about what we want you to do. So remember, phase changes is when matter changes from one state to another due to that thermal or heat energy. So we're going to take a look at this. For example, melting, the first box there on slide 1. You're going to obviously know that it's going to go from a solid to a liquid. So you're going to click on that box and you're going to drag it down into your definition. Just click and drag it down into the definition. So what you're going to do is just match the phase changes with their definitions. We're going to give you about, let's see, 45 seconds there. 45 seconds up on the clock to just click and drag. We're going to answer from the previous slide. So I don't know if Mrs. Larkin wants to go back to that previous slide or not. There we go. So there you go. 45 seconds up on the clock. Raise your hand when you are finished. Raise up that hand. Here we go. 12 of your project. Slide 12 of that project. Up, we have about 27 seconds left. 27 seconds. 6 seconds. Adriana, Alexis, Annabelle, make sure you raise your hand. Angel, raise that hand. And I apologize because it moves really fast. Thank you, Julia. Thank you, Angel, Bryce. See that hand raised. So Adriana, Alexis, Annabelle, Angelo, Canyon, Christopher, Destin. Let's get those Jade Lynn. I know, Jade Lynn, I know you're working on your phone, so just let us know in the chat box that you're okay. Let's see. Keeps moving on me fast. Timothy, Taylor, Preston, Catherine, Jade, Destin, Angelo, Annabelle, Alexis. Thank you, Peyton. All right. For those of you who did not get that, then you're going to have to watch the recording later on this afternoon, but we do have to move on. Let us go on. I'll shut that off.
This one together. So here we go. Water forms on the outside of a cold can of soda. Dry ice, which is frozen CO2, immediately turns into a gas when it gets heated. The sun dries the sidewalk after a rainstorm, and then frost forms on a leaf. You should identify what are each of those phase changes. We just learned them. We also see them in our notes for slide 12 of our project. If you need to refer to that, grab your whiteboard tools. Please use the box tool. Please use the thin version of it, and you can use any color you would like. And go ahead and get your answers up on the whiteboard. Go, go, go. Looking good. Keep on working. Perfect. Lovely. All right, let me go ahead and pause those tools and let's go over our answers here. So taking a look here, water forms on the outside of a cold can of soda. Remember, this is when we have gaseous water in our atmosphere that then turns into a liquid on the outside of a cold can of soda. So absolutely, this one is going to be condensation. Beautiful. Dry ice, on the other hand, dry ice starts as a solid and then turns into a gas immediately. It skips the liquid phase. It goes straight into a gas because it gets hot really, really fast. Perfect. The sun dries the sidewalk after a rainstorm. Rain means it starts as a liquid, and then as it begins to dry, it begins to evaporate, and so that turns into a gas. That is an example of vaporization. Beautiful. And then right here, frost forms on a leaf, making it, there we go. Frost forms on a leaf. Sorry, let me change. Perfect. There we go. Frost forms on a leaf here. That is going to be deposition. Remember that this example, we actually skip the liquid phase, so it's not freezing. It's actually depositing. We go from a gas in the atmosphere straight into a solid on that cold leaf, cold plant. And so we're skipping liquid phase. That one is deposition. Great job, everybody. Let's go ahead and move on here.
So we're going to now work on our slide 13. So multiple answers on this particular slide. This is a complete on your own. So make sure you do not put any answers into the chat box. When you are finished, make sure that you raise your hand. All right, so you're going to complete on this own. In cold weather, water that drips from roofs becomes icicles. Identify the type of phase change and the starting and ending states of matter. So what is going to be that phase change that you're going to do? That's going to be highlighted in the red. That's that first column there. What do you think it's going to do? It's going from water that drips from your roof becomes icicles. Icicles, here's an example. I know we're from California, so we might not know what icicles look like, but here is a perfect example of that. So which is that? Then you're going to start from here, looking at the blue section, pick one from here. Where's my starting? Where does it starting with? And then finally, my green section, what is it ending with? Solid, liquid, or gas? Go ahead and use that. 3 different answers, one for the red section, one from the blue section, and one from the green section. We're going to give you about 45 seconds to go ahead and work on this. Work quickly. Raise your hand when you are finished. Here we go. Go, go, go. All right, looking at 17 seconds. 17 seconds, let's get those hands raised. Again, three correct answers here. A few people here. All righty, so looking for Adriana, May, Alexis, Annabelle, and it's moving really fast on me. My eyes are going crazy. May, Alexis, Annabelle. I'm going to give it a second. A lot of people are getting their hands raised. So let me go ahead. Annabelle, Angel, Angelo, Canyon, Destin. Looking for a hand raise from you. Dion, Jade Lynn, Kale, Catherine, Michael, Taylor, Timothy. Let's get those hands raised. I see a couple people working. Excellent. Thank you so much, Kale. Annabelle, Angelo, Kenyon, Destin, Dion, Jade Lynn, Catherine. I know, Jade Lynn, you are working on your phone, so just let us know in the chat box if you're A-okay. I see that. Perfect. Annabelle, thank you so much for that one. And so Angelo, Destin, Dion, Catherine, Taylor, Timothy, let's get our hands raised. All right, we are going to move on, so you will have to get your answers on the recording.
Yeah, so Stephen, a couple of your slides in your project are just reference slides. So yeah, slide number 9 and 7 and 15 and 16 are all references. Cool. All right, sorry about that, everyone. Okay, so here we go. Endothermic processes are when heat enters. The prefix endo means enters. It sounds like enters, and thermic means heat. So heat is entering into a substance. Now this happens, and what the result is that we're absorbing heat or thermal energy into the substance. It's going to increase the temperature. The particles are going to move faster and faster. As they move faster, they begin to turn into a liquid, or if they get really fast, they turn into a gas. So what this means is that melting, evaporation, as well as sublimation, right, sublimation, are all examples of endothermic processes. Go ahead and give me a emoji in the chat box if you understand. Emoji if you understand. These are all endothermic processes because heat is entering into the water, making it hotter, faster, changing it into liquids and gases. Beautiful. All right, now exothermic, what do you think the prefix exo means? I had a couple people already guessing. What do you think the prefix exo means? Tell me in the chat. Stop. Well, I would say exit. If endo means enters, then yes. Exo means it's going out or exiting. Awesome. So in this case, heat is going to exit or leave the substance. In other words, heat is being lost, all right, from that substance. And so therefore, we're releasing heat or thermal energy. It's going to decrease the temperature. It's losing heat. It's going to get colder. And therefore, the particles move slower. And so they'll turn into liquids, and if they get really slow, they'll turn into solids. So that means that these ones are colder processes, freezing, condensation, as well as deposition. Remember, deposition is when we go from a gas to a solid, skipping the liquid phase. Those ones are all examples of exothermic processes. There is no slide that you need to do for this one. When we tell you to do work on slides, they're all highlighted in yellow, just so you know. All right, so let's go ahead and practice these together, okay? So let's try condensation first. So condensation, we're going from a gas to a liquid. Is a liquid version of a substance hotter or colder than the gaseous version? All right, think about liquid water versus steam. Is liquid going to be hotter or colder? Yeah, to turn something into a liquid, it needs to get colder. So it's going to get colder, which means temperature needs to decrease. As temperature decreases, it's going to get slower and slower. Gases are very chaotic. Liquids are a little bit slower, less chaotic. And that means that it must be losing thermal energy. Remember, thermal energy and heat are the same thing. So it's releasing heat, or in other words, heat is exiting. So if heat exits in the chat box, is this then endothermic or exothermic? Is this then endothermic or exothermic? Thank you, Gabriel. Thank you, Shelby. Thank you, Malin. Endo or exo, tell me in the chat box. Thank you, Ignacio, Angel, Allen. Yes, this one absolutely is going to be exothermic. Let's try vaporization, the opposite process. So this time we're going from a liquid to a gas. So are we getting hotter or colder? If we're going from a liquid to a gas, are we getting hotter or colder? Yep, the gaseous version is going to be hotter. We have to heat it up. Absolutely. So we're getting hotter. We're also getting faster. Gases are more chaotic than liquids, so they are moving much faster. The particles are moving faster. And in order to get hotter, that means it must be absorbing heat, absorbing thermal energy. Thermal energy must be going into it. Thermal energy must be entering. So if heat is entering, is that endo or exo? If heat is entering, is that endo or exo? Yes, exactly. This one is going to be endothermic. Great job. Go ahead, use your whiteboard tools and try to analyze the rest of these. Take a look at what's happening. As we get colder, slower, we lose heat. Think about losing heat. Is that heat exiting or entering, therefore is it endo or exo? And then same thing, as we get hotter and faster, we're absorbing heat to get hotter. So is heat entering or exiting? Therefore, is it endo or exo? Go ahead and get your answers up on the board. Any color's fine, but please try to use thin boxes. Perfect. I see lots of great answers up there. Again, that's why we're practicing together. I know this is a lot of information on one slide, so I want to make sure that we get a chance to practice it. Perfect. Okay, I'm going to go ahead and pause these tools. Let's analyze these, okay? So I'm going to delete these boxes just because we don't need these ones right here. Cool. All right, so taking a look here. When we freeze something, obviously it gets colder. And as it gets colder, the particles have to slow down. Solids are much slower. And that means it must be losing heat or thermal energy. So if we're losing energy, energy is being released. Energy is exiting, making it exothermic. Excellent. Melting is the opposite, so you automatically know that it must be endothermic, right? So, but we can still analyze it, right? As we go from a solid to a liquid, liquids are warmer, so we must be increasing the temperature. Liquid water is warmer than ice, right? So we must be getting hotter. We're also getting faster. The liquid particles can move more than solid particles. And this is not in your project, Stephen. We will tell you when to work in your project, don't worry. And so in order for all these things to happen, it must be absorbing heat. As we absorb heat, heat is entering, and therefore it is endothermic. And then same thing for deposition and sublimation, you'll notice there's a pattern. Anytime you get colder, it's exothermic. Anytime you get hotter, it's endothermic. Give me an emoji in the chat box if you feel more comfortable with this. Again, I know it's a lot of things on one slide. That's why I wanted to make sure we got to practice it a few times. Excellent. All right, so we're going to go ahead and actually on slide 14, we're going to first do temperature together. And then based on your definitions, you should be able to do the rest of these answers. You should end up with 4 correct answers, and I'm going to let Mrs. Pulvita take over.
And this is complete on your own. If I ask you to put it in the chat box, put it in the chat box. If not, just keep it out. We want to make sure we understand this material on our own. So let's complete on our own. A solid chocolate bar is placed outside in the hot sun. Choose all the following statements that are true. We're going to work the red one together. Okay, we're going to work the red one together. So if we're placing a chocolate bar, which is a solid chocolate bar out in the sun, is the temperature decreasing or increasing? What's happening to that chocolate? What's happening to that chocolate? Now, I'm sure we have all done this. Yes, good, James. Yes, Maylin. So the temperature is increasing because the chocolate is doing what? It's melting, like Gabriel said, it's melting. So the chocolate is going to melt, so that means that our temperature is going to increase. With that help, I'm going to go ahead and again, refer up to the kind of the helpful hints at the very top of this slide, but I want you to answer the blue one, the green one, and the purple one. So one answer for each. There should be a total of 4 X's, a total of 4 correct answers on this particular slide. We did the first one for you, so you could go ahead. X temperature is increasing. From there, are the particles moving faster? Are they moving slower? Is the thermal energy absorbed or is it being released? And is that an endo or exothermic process? Use the hint at the very top. We're going to give you about 45 seconds to do this. 45 seconds up on the top. Raise your hand when you are finished. All righty, let's go ahead and just check in with a few people. I know it may take a little bit longer, but that's all right. So with that being said, let's go ahead. Adriana, May, Alan, Annabelle, Angelo, Anthony, Destin. Again, if you're working on your cell phone, that's absolutely cool. Just make sure you let us know that you're okay. Awesome. Thank you, Annabelle, Adrian, May, Angelo, Destin, Dion, Gabriel, Jadelyn, Jaden, Kale, Catherine, Michael, Nathan, Timothy. Let's get our hands raised. Thank you, Jadelyn. Awesome. Okay, so just a few more people. Catherine, Kale, Gabriel, Dion, Destin, Angelo, Amay, and Adriana. Let's get our hands raised. All right, let's go ahead and move on.
All right, everyone. So you can go ahead and skip slides 15 and 16. Those are just reference slides so that you have those diagrams because they're helpful. But we're going to go ahead and take a look then at slide number 17. This one, I would recommend start working on it today, and then we can finish it up on project work days, which will be on Thursday and Friday. So what you need to do is in your food, you need to find one example of a phase change that occurred. Now, all of you are either going to have one of two phase changes, melting or vaporization. And the reason is because your food must be heated, right? We talked about that in when you were choosing your food, it must be something that gets heated. So if it's something like melting, that would be like, for example, cheese that melts from a solid into a liquid. Vaporization is pretty much anytime you have your food heated, it begins to steam a little bit, and that steam is the water in your food becoming a gas. Liquid to gas, that is vaporization. So everybody is going to have one of these two. Even in frying, you are still going to either have melting or vaporization. Okay, like the oil itself stays as an oil, right? You could possibly burn. You could make your oil begin to steam. If you make your oil too hot, it'll begin to burn and steam. So that's also an option, Stephen. All right, so taking a look here, you need to explain what part of your food underwent a phase change. So you would explain, for example, cheese or the steam in my food, right? Then tell me what type of phase change is that? Is it melting or vaporization? And explain what did it start as, solid, liquid, or gas? And what did it end as, solid, liquid, or gas? You should know based on what melting and vaporization are, what you start with, what you end with. Now, in this type of phase change, thermal energy is absorbed, released, so temperature decreases, increases, and particles move faster, slower, therefore it is endo or exothermic. Let's go ahead and actually work on this last part together. So go ahead, take a look here. When we melt something or vaporize something, is temperature decreasing or increasing? In order to make something melt or vaporize, does temperature decrease or increase? Yes, temperature increases. And that should make perfect sense because, again, we said over and over, you have to heat your food. All right, so temperature is going to increase. Therefore, if temperature is increasing, is thermal energy being absorbed, going in, or released, being lost? In the chat box, thermal energy is heat going in, absorbed, or released, lost. Is it absorbed or released? Absorbed or released? Yes, Stephen. Exactly, it's going to be absorbed. Perfect. So thermal energy is being absorbed. And also, if we are melting, turning it into a liquid, or vaporizing it, turning it into a gas, particles and liquids and gases, do they move faster or slower? Particles and liquids and gases, do they move faster or slower? Yeah, exactly. They begin to move faster and faster. Liquids, the particles can move past each other, and in gases, the particles move extremely chaotically. So all that being said, if thermal energy is being absorbed, going into our substance, is that an endo or an exothermic process? Is that endo or exo? Beautiful analysis. Thank you, Gabriel. Thank you, Derek. Ignacio, awesome. I see lots of people in the chat box. Yeah, this is going to be a endothermic process. Heat is going in, it's entering, it's endo. Awesome. So you actually have the answers to these 2 bullet points. You just need to do the rest of it up here to analyze your phase change. Go ahead, raise your hand once you have a picture of this or you have filled this out. I'll go ahead and give you 30 seconds because I want to make sure we wrap up pretty quickly because we're out of time. So 30 seconds. I know that's fast. Take a picture. Perfect, Annabelle. Raise your hand, go, go, go. 20 seconds. Timothy, Taylor, Tayan, Stephen, Patrick, Michael, Malin, Catherine, Adriana, Ame, Alan, Alexis, Angelo, Anthony, Aria, Bryce, Canyon, Christopher, DJ, Dion, Kale, Catherine. All right, again, take a picture. I gave you the answers for these last 2 bullet points. We analyzed those together. and you should be able to do the first two on your own just fine. Again, get it done today. That way you don't have to stress about it later. Perfect. All right, going to go ahead and lower those hands, and we're going to go ahead and wrap this on up.
All right, so today we talked about those phase changes. We talked about the different types of phase changes and the endo and exothermic processes that we just talked about. So with that being said, I'm going to stop the recording here and